Hi everyone, welcome to Building a Data Engineering Portfolio project with Anju Mercian. This is the part 2 of our project. Our speaker today is Anju, and I hand it over to Anju, and yeah, you can enlighten us with the part 2.
Thank you so much, Mansi, and welcome to everybody that's here. Thank you for joining the session. Let me share my screen. Can everybody see my screen? Mansi, can you just let me know?
Yeah.
Okay. So thank you so much for all of you to be here. So this is actually part 2 to the part 1 that happened last week. So last week, what we concentrated was on like a little later, but so when I'll just talk about, if for everybody that's new here, I'll just talk about why to have this or why I created this. Stephanie, is that I wanted to kind of give a template. One second, I think. Can you still hear me? Hello?
Yes, we can hear you.
We can hear you.
It said my internet connection is unstable, so that's why. Sorry about that. So this is kind of like a template that I'm trying to like bring out here, so that anybody that's looking to do like a data engineering project, this will help them. And for beginners, you don't have to really start out with what I'm going to talk about today and what I spoke about last week, but I've already about how to start for a beginner's data engineering project. And also today I'm going to talk about a concept called Apache Airflow, which is actually creating automated data pipelines. The whole of focus on today is going to be on how to create an Apache Airflow. This will not be related to last week's project. I'll start off with what I spoke about last week, but it'll be mostly theory of Apache Airflow, because I thought, the feedback that I got was like, not everybody knows about Apache Airflow creating data pipelines, but it's actually used extensively in the industry to create pipelines. So that's why I thought, okay, I should bring this and maybe kind of give everybody like an like kind of a promo to what Apache Airflow is. There's a lot of depths to it. Even for last week's Apache Spark, there's a lot of levels or of depths to it. You will have to go back and like go deep, work on it deeper. The same way today too with Apache Airflow. It's like there's a lot to it. There's a lot of stuff that you can do with it. There's a lot more to learn. I'll share good resources that I found helpful to me. But this is just literally like a promo. It's to what more can those tools do. So for anybody new here, I just go over who I am. Hi, everybody. I'm Anju Mercian. I have been in the industry for almost 10 plus years. I have worked in various roles like infrastructure engineer, project manager, business system analyst, platform engineer, software engineer also. And now I'm currently working as a data engineer. My data engineering passion was successfully like 2 years back when I was looking to do something else, because I never really found my space, and I came across data engineering, the realm, and I was like, okay, this is where I want to be. This is what I love doing, and I worked on it. I studied. I took a lot of online courses because when I was doing masters, which was like 10 plus years ago, there was no machine learning yet. That was not famous, and it was not known. I took all the database courses, SQL courses, and Oracle courses that was there in what was available to us. But the data science and machine learning is more active now. Actually, 2 years after I graduated is when I started hearing about machine learning. But so I was able to get into data engineering just 2 years back, and now here I am today. That's me. So the agenda for today, if anybody wants to contact me, this is my website, anjumercian.me. All my contact details are there, so you can contact me through LinkedIn. I'm very active on LinkedIn. So if you have any questions or want to talk, or want further help, or have any questions, doubts, if you can't ask here today, I'm also on Women Who Code Slack. So you can also ask there. Actually, after last week's meeting, I got to meet so many people, and I was very excited that so many people are interested in data engineering. So, so you can contact me. And so the agenda for today is I'm going to give a slight recap of what we did last week, what all we looked at last week. And then I'll go into what data quality is and what are the data quality that we can look at for the project that we saw last week. Then I'll talk about data pipelines, data partitioning, backfilling. Now, data pipelines, data partitioning, and backfilling are something that's related to Apache Airflow. It's kind of like theoretical before we go into Apache Airflow. Then I'll talk about Apache Airflow, what it is all about and everything. And then we'll look into the Apache UI. I have just a few examples that I have built on my system, standalone server. And we'll look at that. And if you have any questions, you can keep writing on the chat, Q&A, not chat. Please try writing Q&A. Then Mansi will try to get to it at the end so that I'll answer all the questions at the end. Okay, so last week what we did was I had 3 data sets that I'm looking at, which is the housing data set, the crime data set, and the climate data set. So when I looked at this one, the questions that I'm asking this data set is like, what is the crime rate based on weather? Like, are there more crimes in summer or winter? Then what is the crime rate in property data? That's usually what people ask, right? Like, oh, hey, if there's more crime, this property data. That is basic knowledge, but I was like, okay, let me see it in visualization in data. That's when I thought about that. Then we looked at property. Then we can also ask the question like property rates based on weather. So in summer, is it like a selling market, buying market, or in winter, a selling market, buying market, So that's what the data set we were looking at. We looked at it from the Pandas viewpoint. We looked at it from a Spark viewpoint. So last week it was all about Spark and Pandas. All of the recording and the last week's presentation, I think Stephanie will already share it in the resources section. And also I will be writing a blog for this and I'll share that out too, so that if anybody didn't catch, anybody was not able to attend the last week's session but would like to take a look at it, we'll share that out. So that's what we looked at last week. So then these were the 3 data sets we were looking at. So this is where we explore and access the data. I have all the links here in this. So when I share out this, you get the links there. This is all public data sets. There were no personal data that was there, and also it's non-Kaggle data sets. I was mentored early on this saying that try not to use Kaggle data sets, because Kaggle data sets is the most cleanest and most used data set. So it's not a challenge. So when recruiters, especially recruiters that know Kaggle and know data science, look at it, they'll be like, Kaggle data set, it's like everybody knows. But if it's different if it's a challenge, but if it is the data set is already available and the challenge is already over, then it's different. But if you work on a challenge, that's different. So I always try to take non-Kaggle data sets. It's actually very challenging working on non-Kaggle data sets. So that's why I share that with others to try a non-Kaggle data set. And there are lots of public data sets available. Okay, so this is the model we kind of defined last week, the fact and the dimension tables and everything. Now, today's session is not going to be entirely based on this, but the knowledge of this data model is kind of necessary in helping us prepare for the ETL pipeline. What's an ETL pipeline? Is extract, transform, and load pipeline. So knowing this is kind of this is what we're trying to build, and we're trying to automate this with Apache Airflow. Airflow is actually a tool that helps automate data pipelines, like creation of all this. So that's every time you don't have to keep creating all this with the data set, you can just start using it. That's what automated pipeline is. So you're going to base it on this kind of data model. Okay. So that's the recap. Now, for today's session, we'll go into data quality. What is data quality? So data quality basically answers the question, how is my data? A high quality data is actually one that can solve the problem of a downstream user. So we have a business use case. if our data is able to exactly solve the business use case, then it's high quality data. What does it mean by that? It means that the data must be of a certain size, which we may have already discussed in my requirements. Okay, the data must be of a certain size. The data must be accurate. There can be a little margin of error, but that should be very, very less, 0.001. Like, for example, they're looking at iPhone data, for example, right? So they're looking at sales data. So the sales data must not have a huge margin of error, right? That will, if they're using that for forecasting, or if they're using it to put out their business value, then that is not good, right? So the data should be of very high quality, especially in those marketing and sales regions, have finance based on that. So so making sure that it is free of error, that is data quality. Then data must arrive within a given time frame from the start of execution. This is basically comes when you're using a data pipeline, like every day or something, like when we want. So if you have created a dashboard, and the dashboard, some of the executive level is looking at a dashboard, that it shouldn't be like in the circle, that buffering circle, the dreaded buffering circle. It shouldn't be in that circle for too long. So as a data engineer, your duty is to make sure that anybody that's seeing your dashboard must not be stuck in that circle. I know there are many cases where the data is so huge that there's a lot of calculations going on behind the scenes that it takes a long time, the buffering. So that is something we should always be aware of, especially when it's going to the management level, right? You should make sure that it comes up on time. So as soon as they can wait like 1 or 2 seconds, like less than 30 seconds, but by the time their brain is ready, they must be able to see that. That's making sure that is there, that is data quality, and that's the duty of a data engineer, to make sure that's there. Then pipelines must run on a particular schedule. So actually, as a data engineer, that's my everyday work. In the morning, I get up, go into the pipelines, make sure all my pipelines are running, or I immediately get a call from the manager saying that, hey, this pipeline is not working, fix this, and that's the duty of data engineers. So you should always make sure that the pipelines are running on schedule. That's one of the access to data quality. Then data must not contain any sensitive information. That is actually relatively new after all of the privacy issues that we have had in the recent years. Trying to make sure that the sensitive information is not going outside the company, and also within the company, within only very small people should know, who have high level access. And I also face this. And when you have high level access, you must make sure that you have to get, you must renew your access every 90 days or every 30 days. So all this is part of a data engineer's job. And that's how you make sure that the data quality is there. Right? So in our core, or at least in this project, what I was thinking of my data quality checks would be is making sure the primary key is distinct. Primary key should always be distinct. So I'm going to make sure that the primary key is distinct. There are no duplicates there. Foreign keys are not null, because now if it's looking for crime data for a particular region, a particular year, and that's what we look at. I'm going to move, trigger warning. I'm going to move fast. So these are the foreign keys, right? So if these foreign keys are not there, they're not going to talk to the other tables. So we need to make sure that the foreign keys are there. That's the part of a data engineer. That's my duty, to make sure that's there. And that is something I'm going to check. Okay, trigger warning. I'm going to move my slides. Then the rows are all intact when moved. So whenever we are taking data from a backend database, from a big data, we should always make sure once the data has arrived onto the destination system, that all the rows that we wanted to be copied are copied. So that's what I'm going to do, because now my next job is I'm going to split all this into tables, split the data from what I have and put them into a different table. So that time I need to make sure I'm just splitting, I'm not deleting the rows. So I'm just splitting the rows, the columns. So all the data, the rows must be checked. Okay, if my original table had 1,000 rows, my end table must also have 1,000 rows. That's something I'm going to check. There are not too many nulls. All the nulls are going to be filled in, because nulls, usually they say data engineers will make sure the nulls are filled in, is because sometimes nulls is a blank row in a blank row or a column or a data, and it's sometimes blank. So when there's a blank and you're trying to do any aggregate functions, it'll fail. you may think, hey, it's only a blank, it's a null. So, but sometimes nulls can also be like string nulls, and they'll cause an error. So always you need to make sure that the null is filled in with a 0 or with an NA, so that all your checks can be correct. Otherwise, you sometimes feel, especially when you're looking at large amounts of data, you'll feel issue. But that is also something you can also have in the requirement. In the requirement, you can ask, hey, if there's a null, what do we do? Usually that's a discussion that's had when there's a null, what do we do? So null is usually can be null or 0. In my project, I'm thinking I'm just going to leave it as 0. So I have good aggregation, because most of the time I'm going to do aggregation. So I'm going to leave it as 0. That is the reasoning behind why I'm using 0 or a null. There should be a reasoning behind why you do something. Then data must not contain any sensitive information. This is public data set, so no. So that's some of those checks I'm doing. Then, so data quality also contains data validation, right? So all the data that is present is correct and meaningful. That is data validation, and that is actually part of data quality. You may think that it's synonymous, but it's not. Actually, I found out later too that it's not synonymous. Data validation is actually part of data quality checks. So data quality is a measure of how well the data set satisfies the intended use, like how I began talking about. There's a resource here. So when you get this presentation, you can look at the resource that has very good resource on data quality and what it means and what we need to do and everything. Okay. What data pipelines is. So from here, what I'm talking about is actually for the Apache Airflow. It's kind of the prepend to what I'm talking about Apache Airflow. So what is a data pipeline? A data pipeline is a series of steps in which a data is processed. So like, for example, the ETL. In the ETL, what we're doing is we're extracting the data. Now in the project that I'm showing, I'm taking in data from different sources like CSV files, Excel files, and JSON files. Sometimes in companies, you may not take data from outside world. It'll be from internal use. It'll be like collected from data. So you'll have to like take data from Hive or from Redshift or from S3. From S3, not Redshift. S3, that's a storage system, or from Google Cloud. So extracting the data from different sources, that is extract. That is one step of the data pipeline. Then you're transforming the data. So you're doing exploratory data analysis. You're cleaning the data. You're transforming the data to the requirements. That's what the transform step is. Then you have load the data to a dashboard or to a warehouse or to a data lake. Data lake is like a data warehouse, but it's in a different format now. Right now, data lake is what is spoken about a lot more. I wanted to cover that here in this presentation here today, but the problem that I had was it was exceeding the time, so that's why I didn't write about it. But I'll make sure to put something out for that. So this is a data pipeline. So I hope this can help you visualize what a pipeline is. So getting the steps done. So like you have a function to extract the data. You have a function to fully clean your data and put out a clean data set. And then you take the data and loading it. That's a data pipeline, right? So we have something called an ETL, which is extract, transform, load. Then we have something called an ELT, which is extract, load, and transform. Sometimes there's a need to just extract it, load it somewhere, and then transform it. So basically you're taking it completely. Okay, so for example, this project that I'm talking about, my crime data set, housing data set, property data set, I'm actually taking it from external sources like CSV files and Excel files that I've downloaded from the internet. What I can do now is take all the data, load it into S3, and from X3, I can do the transformation. And then I'm not loading it anywhere else. I'm just transforming it and putting it out in a visualization. That is extract, load, and transform. Now, why data pipelines? So data pipelines was not very famous when there was Hadoop and MapReduce. So MapReduce did not really care about data pipelines because they were reducing the data and then they're mapping the data and then reducing the data. That was their ideology to work on big data sets. But with Spark and with later versions of the newer versions of big data processing, they understood that using something called DAGs, which is directed acyclic graph, is much faster and can help parallelize the processing. So that's when data pipelines became very prominent, very useful. So you can break down your data pipelines, which I'm going to talk about, like called data partitioning. And if it's based on size, you can have one system doing a smaller data set and another doing a smaller data set. You can parallelize the process, but again, you're coming back to load it or to transform it. You can, so that will help parallelize and make the process faster. So that's when data pipelines became very popular. So data pipelines are well performed as DAGs. That's to use DAG. That's when data pipelines are popular. And Airflow actually automates these DAGs, the directed acyclic graphs. What is a directed acyclic graph? Like actually, I think every mathematician, every software engineer, so computer science engineer will know. It is a graphs. It has something called nodes and edges. So like the picture here that we have, like the picture right here, we have A going to B. So there's no cycles in here. There's a direction. So we know clearly A is going to B and A is going to C, and B is going to E and C is going to D, right? This is a directed acyclic graph. For example, like Facebook or LinkedIn, they use these graphs to connect people. So there's a first connection, there's a second connection, there's third connection, and all that in LinkedIn, right? That is using graphs. To connect, so the person is the node, and the connectivity between LinkedIn is the edges. That's exactly that's the graph, right? And that's what we are showcasing here too. And that's how this is also considered. Your ETL is also a graph. Your every function that you're using as an extract, transform, and load are nodes, are considered nodes. And the connectivity between them, calling one function from another function is your edge. That's how these data pipelines are transformed or are considered. So that is about data pipelines. Hope it's clear. Okay, now let's come to data partitioning. Like I spoke about is, there are two things why we are doing data partitioning. Data partitioning is one, to help parallelize and make performance faster with partition data. If you're partitioning by size, that's what we do. Or when you're doing a partition by schedule, you can say, okay, hey, so if this time sensitive data, you're like, hey, okay, I want only yesterday's data. Yeah, like if you're looking at how many products are sold, or how many people are looking at your or something you wrote, or looking at your videos on YouTube, and you want to know by day or by month or by week, that's by partitioning, right? So if you partition by data, you'll know for 1 day how many people watched your video, for 1 week how many people watched your video. So that is data partitioning. So you partition data, isolating the data to be analyzed by one or more attributes is data partitioning. And there are 3 types of data partitioning that has been conceptualized. One is schedule-based partitioning, one is logical-based partitioning, and size-based partitioning. As you know, size-based partitioning is based on size. Airflow actually has very limited memory. So if you're using it on your system and your system only has 8 gig memory, only that is the only memory you can use. You can't extend the memory of that. So when that is the case, you can actually break down 100 gigabyte worth of data into 8 bytes, 8 bytes, 8 bytes into different systems that is running Airflow, and break them down and have them run it so they can automate it based on size. Based on logical partitioning is based on the logic, right? Like for example, all of the extract can be one partition, all of the transform can be another partition, and loads and all are different partitions. So based on if they don't have to talk to each other, then actually that's the way it be. If they don't have to talk to each other, so that will be logical partitioning. Schedule-based partitioning. If time is key, if time is what is important here, then it is based on the time. Usually many systems and many data storage use Unix time. That is well-established time in the computer science world. Unix time. It's, if you see Unix time, actually you'll know what it is. There's a start date to that Unix time to when the system started or something, or when systems are calculating time. So most of the stuff that I have seen so far is Unix time, and then you have to convert into date time. And all SQL and pandas based libraries have this conversion. So usually if it's time based, it is based on schedule and it's partitioned by time. I work on a lot of partitioning by time. I know many people do work on partitioning by time. That's well, Airbnb work partitions by time. I've also shared one link by one of the Airbnb data engineers, or ex-Airbnb data engineers, who have spoken about how they do everything partitioned by time and create the data pipelines partitioned by time. So that is data partitioning. So basically, data partitioning is splitting the data. Okay, so a few more things why data partitioning is helpful is when data fails or something fails, right? You know where to go and look at. So if you know that day before yesterday's pipeline failed, day before yesterday some task failed, you know where to go and see. And if you're partitioned by a logical concept, you'll know which function to go and see. If it is based on size, you know which system with that much size failed. So it'll be easier to debug and find the which one failed and how to and get that resolved faster. So debugging, rerunning will help with data partitioning. Then again, redoing of work, reducing cost over time. Debugging is hell of a work. I know every computer engineer or data engineer will know how debugging is a lot, but whatever helps us with that, and data partitioning does help with that. You know which part to go and take a look at. Then if the data is partitioned appropriately, your task will have fewer dependencies on each other. Time sensitive data by date time stamp is ideal. So for time stamp data, like I said, date time stamp is what is needed. Okay. Now we'll talk about data lineage. What is data lineage? Is basically, you know exactly from where you're taking the data, So the whole process of where you've collected data, where you're storing the data, everything is, you can take all of that and be represented and represent that in your Airflow or data pipelines, whatever you write, because that is important to know where you got your data from. Accountability is important, especially when it's time-sensitive data or very data-sensitive data. That is very important. So data lineage is important. All the systems built for big data have this data lineage, so you can actually trace back to where the issue came from. If your information about all of your phones, metadata about your phones is stored in some Apple, if you're using Apple by any chance, it's stored in Apple big data hive. I don't know what they use, but if they're storing like a hive, then they know exactly, hey, okay, this data has come from here. We know which kind of support system that the data has come from, and you'll be like, okay, why the data has come. So that accountability is important, that data lineage is important, and that's why all big data tools handle this data lineage to help ease the defining of metrics for debugging and for basically instilling confidence too. So your downstream people, your customers know that, hey, yeah, okay, so this is where it went wrong, or this is where it went wrong. So they'll have confidence as, okay, this is what happened. So data lineage is important. That is also there in all the big data tools. Now, backfilling. So what is backfilling? Backfilling, as the name suggests, is filling backwards. So you had written a code today, and you're like, okay, I have the data from today, and from today on, further on, you'll capture the data. But what if you want the previous data, right? So in order to fill the previous data, the data is available somewhere in the big data, but for your code, the previous data is not filled. That's when you do something called backfilling. And every pipeline, every tool that automates pipelines have the backfill. So it basically goes back in time to the time that you want and tries to fill in that portion. So if you have the data available, this is only because if the data is available. So a DAG run, which is the run to complete the task, instantiates from the start date to the end date with the schedule interval it runs, but it can also do a catch up of the previous a run too. That is what backfilling is all about. I hope that's understandable, because in my head I can understand it, because it's something you're filling backwards when the data is available. But you created a program today, but the data has been collecting from 1 year back. So now you want that data to be filled with your code. So you go back and fill in time. You may think that's easy, but when you're manually doing it, you have to go see the date and do it, and say, oh, okay, this is filled here. Okay, let me take the data, let me fill it. That's manually done. Like if you do it in Excel manually, you'll go to the 1 year back and try to gather the data and fill it in. But backfilling in systems is like you just say, okay, from January 8th to 2021 to February 8th, 2021, please fill my tables. It'll go fill it for you. And the data was available, so you'll just go pull it in and fill it for you. That is backfilling. And backfilling will also run only if there's no like if the dependencies will be first run, and then the backfill for your table will be run. That is also there. So that is backfilling. Okay. Now we come to Apache Airflow. So all these concepts we talk about in Apache Airflow. Okay, this is actually a link. So this link actually goes to your Apache Airflow documentation. They have wonderful, beautiful documentation. Everything that you need to know is already here, very beautifully written. They talk about everything. And then there's something called a quick start over here. So in quick start, you have 2 things that is available to you, running locally or running in Docker. I actually suggest running it in Docker. If you're running it in Docker, they have all the steps. And also if you go to Docker's website, they also have all the steps how to run Docker in the system. But what I did was I actually ran manually on my system, locally on my system. So I followed this and I ran out over here. I'm thinking I'll just show you my local DAG run, and then we'll go into talking more about Apache Airflow. So just give me a moment. Let me unshare and reshare. Wait, maybe I should unshare and reshare. This is actually, okay. Give me 1 second. Let me unshare and reshare. Okay. This time I'll share my whole screen. Okay. I'm sharing my desktop. Mansi, can you see my screen? Okay, so when you have run your system, see over here, if you see, they have everything perfectly written, right? So if you have Python, I have Python version 3. So when I had to do Python version, I had to do Python 3 -- version, and then the rest were okay. And I think one more place I had to do Python pip install. I had to do pip install 3 because I was trying to install Python 3. And then when you run Airflow space standalone, and that brings up your Airflow in your system. Now that's what I'm going to do. I'm going to do Airflow standalone, and that will run the standalone server. Yes. The live presentations usually have this thing when nothing is sometimes won't work. So I'm crossing my fingers. It just worked before. Okay, starting. Okay. Okay, yeah. So now you have to go into localhost 8080. Localhost 8080, and that this is my system DAG that's showing up in my system. How I know is because I created a Hello World project for myself, and that was run. So this is my run that is there, right? And I also created a tutorial, and this is also my run that is here. And we'll go over that. I just wanted to show you because before I got into Apache Airflow. So this is Apache Airflows Ui. So you see all your tags. So if you go click, this is all your tags, right? You have your security, you can have users, your roles, and all. Then you have your different diagrams, your triggers, your audit logs. Okay, then you have admin, you're the admin, and then you have all these are all how you can put external variables. So variables is basically you can put external, like if you're trying to connect to AWS, you can put it in AWS details over here, and it's very safe, and they will make sure it's safe for you, your AWS secret key and everything, and then you can configure your connections. We'll talk more about that. So all that happens under admin, and then they have very good documentation too. So you can look at the documentation, and this is the Apache UI, and these are all the tags. These are all the example tags that they give you, and then you can also write your example tags. Looks interesting, right? And if it's success, it shows a success over here. If it has failed, if it's skipped or failed, it'll show us in red, and you can see over there, and actually go and click in it and see what happened in that, all the beautiful stuff. Anyways, let's go into our Apache Airflow, talk about that before we go and look at an example. So what is Apache Airflow? Apache Airflow is actually an open source tool that was created by Airbnb to automate your data pipelines. So that a data engineer's job is not only doing this, right? So it automates the data pipelines. Once you create a data pipeline, put it back as part of the Airflow, it'll automatically run based on the schedule you've given. It's actually written in Python. Beautiful. It's actually, all of these automated tools are very high level right now. You don't need to do a lot of low level stuff. It's very nice nowadays. And one more main thing, which even Airflow will tell you, and any other, there's also something called Data Swarm, but Airflow is openly available for everybody to use. So I think Data Swarm is open available, but Apache Airflows now, Google is also handling it. They're also open sourcing it, and they're putting in their data too in this. So one thing Apache Airflow will also say again and again is that Apache Airflow is not a it's actually like a config file. It is not where you can actually stream data, do what Pandas does, or do what Spark does. It is a configuration file where you say run this, it'll run for you at the specific time. Over there, you can't do all of what you do in Spark. You can create it as functions and have those functions written in Spark Python or Spark SQL, and have them do that, but it's mostly, it's actually a config file. And that's something to remember. You can't expect to be moving data between different files, reading data from different files. That should all be in functions that you're calling from the DAG solution, your DAG instantiated operator. A task would not move data from one source to another through tasks. They can exchange metadata, but you can't do what Pandas and Spark does in Airflow. It's a config file. So workflows is how your tasks are defined, expect to be mostly static or slow changing. This is something I've personally experienced too. If you try to change existing DAG or an Airflow, it's very difficult. You'll have to just chuck it and say, I'm going to go create another one. Like you're changing a user, like one person built it and you have another person use it, you change the user. It's difficult to get that reconfigured. You may wonder why you have to do it, but usually it's not meant to change every day, right? So it's not built to be changing every day. It's a code that's supposed to be written and just forgotten to be run all the time, except there's an issue. It's like that. So if you're trying to change something or changing the DAG instantiated name, that has happened to me many times. I'm trying to change the DAG name and I'm trying to figure out why it's not running, because it's not really understood that it's a change. So they're not expecting your workflows or the DAG information to change a lot. So that is not built in to Apache Airflow or any other automated pipeline configurations. That is iffy, but it is, what do I say? Yeah, but it's nice to automate your configs, files. It's like a cron job that will run behind the scenes. When you're sleeping, it's filling up your tables for the particular data partitioning. And then it's ready for use the next day. It's like that. But if you, that's all. And then Apache Airflows are expected to look similar from one run to the next run. So basically for every run, it's Suppose if you're changing drastically, like we're changing the code of it drastically, it's better to leave that DAG or delete the DAG and create another DAG. That's always that is good to do. So that it knows, so it'll be easier to backfill, it'll be easier to do any catch up that is needed. That's why I always start new if needed. This allows for clarity around unit of work and continuity. So this is the definition of what a DAG is. So DAG is basically to programmatically author, schedule, and monitor workflow. So now if you saw the UI, you saw all the DAGs that are there. So you can monitor it at one angle, which ones are running. So if I had all of it on and it was running all the time, I'll know which one failed, which one skipped, which is running fine, with the green light and everything it will show. So it's basically like to do a cron job on it. So you author it as a directed acyclic graph, and I'll come back and show you the graph so that all your task dependencies can be seen as a graph. I'll show that to you. So that's why we need, so basically to automate your data pipelines is when you need that. Okay, so the components of an Airflow. So there are 5 components to an Airflow. There's a worker, there's a web server, scheduler, worker, queue, and a database. Web server is what I just showed you, your web UI. Your scheduler is actually what schedules or triggers your Apache Airflow to start running. So if your scheduler is like scheduled to like run daily at a particular time, you tell that to the, you configure that in your pipeline and it'll run that night. So every night at 1 a.m. run it, it'll run every night. If it's like hourly, it run every hour. So that is what triggers your tasks, your pipeline. Then there's a queue where all your tasks will go and wait in the queue, and then there's a worker that will work on the tasks. Now, there's a database. The database only is mainly used as a metadata to store your information, the admin information. It's not like a Postgres database or a S3 or a Redshift-based database. It's not a big database. The Airflow itself was designed to be used as config as like the high end high end to run your data pipe, to automate your data pipelines. It doesn't have a database to treat your data, to work on your data. It is the database that's available here is only to store your metadata. And most of the time, they also Airflow itself will advise you to not use this database ever, and use some other database like an AWS storage, an AWS Amazon-based or Google-based database. So these are the components of your Apache Airflow. Now, how does Apache Airflow work? I already spoke a little bit about it. I'm going to go in detail about it here. So the starting point is your scheduler. Your scheduler is triggers based on the schedule that you say on the start date and the end. So 3 main things that be important is start date, end date, and your timing, your schedule timing. So on the particular start date that you say, at the particular time you say, and to the end date. If you don't give an end date, it'll constantly run until you stop it. And end date is not actually very important, but you need to be aware as a data engineer that, hey, I need to stop this if there's no end date. So usually data engineers always give an end date, and then they go back and switch it on after every 3 months. That's kind of the rule that is followed internally. So based on your scheduler's trigger, or a trigger from external, like basically you go in and run the data pipeline. These are the 2 triggers that happen for the scheduler. So scheduler will take it and go take a task. So for example, here in this picture, I have a task that says, pull data from HTTP and pull data from S3 and take it to Redshift. That is one task, pulling data from HTTP and pulling data from S3 Redshift and putting into another into Redshift is one task. And that's how you see the edges over here, right? The edges and the nodes. So my tasks that currently, this is actually conceptually broken into different broken. So partitioned by logic. conceptual of pulling data from HTTP. So basically it's pulling data from the web, it's pulling data from S3 into Redshift. That is one task. That task is taken by the scheduler and queued. Okay, it will be placed in the queue, and from the queue, based on when the worker is free, there'll be many workers, but if all the workers are occupied, it will still be waiting in the queue. So based on that, it'll take, once it's done with one work, it'll take the next work, and it'll work on the task. So one worker's duty will be to pull data from HTTP to Redshift, and another worker's work is to pull data from S3 to Redshift. Okay, this is how an Airflow works. Hopefully this is clear, kind of. And if you see, the database is just laying there to get your information as an admin, or who was the admin. Any of the metadata that you need will come from the database. It's never really triggered. It's triggered only when you're trying to open your Airflow, your information, your personal identifier information comes from there. Usually in companies, it's actually stored elsewhere and it's pulled in because you'll have your company email and everything, right? So something like Okta will pull in your data or something like that. So that's how this happens with Airflow. Hopefully it's clear. I'm just leaving this. So scheduler triggers, and then as soon as the trigger, the one task will go into the queue, and it will wait for one of the workers to be free. As soon as the worker is free, the worker will work on the task. Will pick up the task from the queue and work on the task. Now that's the order of operation. So the Airflow scheduler starts the DAG based on time on external triggers. Once the DAG is started, the scheduler looks at the steps within the DAG and determines which steps can run by looking at the dependencies. I'll talk about what dependencies are in one of my example code. Then the scheduler places the runnable steps in the queue. Workers pick up those tasks and run them. Once the worker has finished running the step, the final step of the task is recorded, and additional tasks are placed in the scheduler until all the tasks are complete. Once all the tasks complete, DAG is complete. So basically, if there is a dependencies, it will wait for the dependency to be complete, and once it's complete, it'll close all of it is complete, it'll close the DAG. That is the order of operations. So scheduler to the worker, if there is more dependencies, it'll go back to the scheduler and then come back. And once all of the whatever is written in a particular pipeline is done, you're good. Okay. So now how does Airflow operate? How do you tell Airflow what to do? So there's something called Airflow operators. That is the higher level building, that's a building block for Airflow. Like, for example, you're trying to do something in Python, something called Python operator that we can use. Or you're trying to do post, okay, so suppose, for example, you're taking something from a Hive data, from an S3 to Redshift. Then there's something called an S3 to Redshift operator. So basically that's like a wrapper. If you know Python, how Python flows, you have class inheritance, inheritance, all of that stuff. So this S3 to Redshift operator is inbuilt Airflow operator that actually will do all of the behind the scenes work of pulling the data from S3 to Redshift. So if you just use S3 to Redshift as instantiating, that instantiating operator will go and do the work behind the scenes, right? And those operators are actually the key to how Airflow works. That's all of I'll show this, right? I know I'm talking about it, you may be confused as what's going on. You will definitely have to come back to this again, but I'm just going with the flow. So I'll show you what these operators are. So they basically do the behind the scenes. So when you're given an operator, so you're saying S3 to Redshift, you just have to give them the details, like which S3 bucket to take a look at, what is the AWS credentials, because your Airflow will have to go into S3, it'll need your AWS credentials. You just give that as one of your attributes, AWS credentials is equal to this, and then you will say, okay, this S3 bucket name, what parameters to look for, all those information, just give it, and all of behind the scenes work will be done by the operator. That's a wrapper. So they're like wrappers. Operators are Python classes that encapsulate the logic to do unit of work. Understand? So all of that, it's written in Python. It's just the Python logic that you use of class and of inheritance and a parent class and child class and all of that. So it's a wrapper that encapsulates all of the logic. So this Python operator. So the different types of Python operators is the Airflow operators. There are different types of Airflow operators. Python operator, Postgres operator, Redshift to S3 operator, S3 to Redshift operator. For some reason, Apache Airflow and AWS are very close. So if you're using AWS and you're using Apache Airflow, it's very easy. But if you're using Microsoft Azure or GCP, I think Airflow operators are being built right now, but currently I think there is, but they're being built right now. That I attended one of the conferences and I know they're building something like that for Google. But right now, if you're using AWS, there are many things already inbuilt in Airflow. Then there's a bash operator, there's simple HTTP operator, and sensor. So for example, if you take Redshift to S3, all of the details, like I said, to how to get data from Redshift to S3 is done behind the scenes, and all of that is encapsulated in the Airflow operator. Now, for example, I said Google, Microsoft Azure. Let me take a Microsoft Azure example because Google is being built. Microsoft Azure, they may not have a way to create the connection or have built-in operators. For that, you can actually have your own built-in operator. You can you can create your own built-in operator. For that, use something called connections and hooks. So in connections, you actually define what are the different sources, all of your variables, what connection you're looking at, right? Your variables that you need to change, and all of that will be built into connections. And there's something called Airflow hooks that will write, that is actually the hooks is how your operators are built. So it is kind of, you're building using connections and hooks, you're building your custom operator, right? So your hook is actually a high-level interface to an external platform that lets you quickly and easily talk to them without having to write low-level code. So hook, the way you define hook will be same as how you define Postgres operator, but you'll have extra steps. That's what I'm trying to say. You'll have extra steps to create it. So you usually use a hook if you don't have already built-in operator. Like for example, Slack over here. Slack, it doesn't have its own operator. So you will create a connection to Slack, and then you'll create a hook to use connection, and then process your, like for example, you want to send some messages to Slack after your tasks are complete, you want to send messages to Slack, then you create a Slack hook. And you enter all the details of your Slack details and what message to send, the message content, and when should it function. So after this particular function is complete, send me data saying that this function is complete. All of that will be written in your Slack hook. But Postgres actually already has an operator. So if you're using Postgres, you don't need to use hook, but Postgres hook is also available. So if you want to make any more dynamic changes to your operator, you can use that. So this is a code that I wrote in one of my classes that I took. So in this a good example. Why I took this example is because there's an example of a hook of a host. Okay, there's an example of a hook, and then there's an example of operators. So in here, load data to Redshift. We're using the AWS hook, which has been created, and a Postgres hook to basically run your commands. So you're trying to here, if you see, you're running your SQL commands on your own, and this is how you create a hook. Now, okay, and then here, your Python callable. So here you're doing a Python operator, which calls a Python callable. So you're using a Python operator because you're going to be using a Python function, and you need the operator to perform this Python function, right? So that's when you have to do something in Python based, you use a Python operator, and you do your what is that? Your function. That is how. Okay, now let me go to my examples. So this is a example Python DAG that I've created. This is a hello world DAG. So I'm creating a few functions. So here, in order to do this, I am taking in the data.
Anju?
Yeah.
Anju, could you please increase the size of the
Oh.
font? It's very difficult to read. Thank you so much.
Right. You good?
Maybe just a slightly more.
Huh?
Okay, thank you.
Thank you, Stephanie. Okay, so here what I'm doing is I'm importing a datetime, a logging function. Why I need login is because I'm just going to log those information. I'm not doing much with it. That's my tutorial. So, and then I'm going from Airflow. I'm importing DAG so that I can instantiate my DAG and work on my DAG. Then I'm importing one of the operators of Python, the Python operator, because I'm going to be working on Python-based functions, right? I'm going to be using that. So that's what I have. So I'm creating my Python functions here. And then here's where I am instantiating my DAG. For a DAG to be successful, you need to have a DAG name, which is actually called a DAG ID. So you need to have your DAG ID, which for me is hello world. You need to have a start date, which I'm doing it as today, and then from time delta of 2 days from today. So I'm starting it. My start date was 2 days back, and my schedule interval, because so that will trigger my. So these two, the start date and my schedule interval, will trigger my DAG run. So here I'm telling my DAG run is basically to run this hello world task. Yeah. Okay. So now how I tell what tasks to run, I'm going to come to that. Then I'm creating different operators. My hello world operator, which will say hello world. Okay. My Python callable is my hello world function that I've written. And my DAG is this DAG I've instantiated. So this is one operator. This is one task that I have. Then another task is my addition task. My addition task that has the Python callable. And the Python callable, this function I've already defined over there up on top. I've already defined the function. Here I am only calling the name of the function here. So I'm saying Python callable, call the name, and my DAG I'm instantiating to the DAG that I just created here. Then the same, so this is one task. So my different tasks that I here. So then I have addition task, my subtraction task, my division task. And this is what I'm trying to get. So from hello world has to go to addition task and subtraction task. So addition task and subtraction task has to wait for my hello world task to complete before they can start. And both of them must end up on the division task. Okay. So this is something like your node, right? You're exploring, exploring, transforming, and you're extracting, transforming, and loading your data. Those are like, so these are the nodes, and these are my edges. My dependencies are my edges, and my tasks are my nodes. So this is what I want. So this is how I configure my tasks. So yeah, there are two ways that you can do. One, you can say set dependency. You can use the function called set dependencies to create it, but the best way to use is to use your greater than operator and the less than operator, your double greater than less than operator. So this operator here says, hey, hello world task, and then work on my addition task. Okay, finish the hello world task and then work my subtraction task. My division task has to wait for my subtraction to my addition task to finish before this runs. So this is how I am talking about the dependencies. So the task dependencies. This is how it is. So this is what I created as a hello world project. Now let me go and rerun my, I think I have to, oh no, I'm running it. Running my DAG. Now I'm going to my hello world. I'm doing my hello world. Sorry, it's slow. It's because many things are running right now. And running down. I'm trying to go. Okay, yeah, finally got it. Okay. So now my hello world task, I switched it on over here. You can pause or unpause here. So I switched on my DAG. Now I can see it in a grid view. I can see it in a graph view. Now see, if you see in my graph view, hello world task is running, is run successfully this time. Okay, now my addition task ran, my subtraction task ran, and now it's waiting on division to run, and it ran. So all of my code, it's very simple code, right? So everything was successful. It ran. You can see that. So now even if you have your tasks, everything based, you will see it over here. So if it is success, it will be in dark green. If it is in light green, it's running. So all that is clearly said over here. Now that is done, right? Now I look at my code to make sure that the code that I have written is what is here. This is very important because if you are changing DAGs, you change the DAG name, sometimes it doesn't get captured and you can catch it over here. It's run over here. Now you can get all the details of when I created it, what is the name of the task, my task IDs, my task name, everything is here. All of the information is here. Now, I think I'll go to my graph view and show you where I put in. So if you go click on that task, you can go and take a look at the log because I actually logged it. So here, if you see, you get all my logs. So here, if you see, my hello world is printing 10 by 2, which because that's what I put. 10 by 2 is here. All of my code will be here as info. So I'm logging all of that information. And because I looked at the division, I am getting my division information. Now, if I go into the graph and go for my addition and go into the look at the log, I get my log and my addition information here, you know. This is a very simple example. I just wanted to just start everybody like looking into it or thinking about it. And you also see that what is the schedule? The schedule is very important and you'll see it next run when it's going to run, right? So it's going to run only tomorrow at like midnight. The subtraction task, if you go, so if you see this upstream and downstream, right? So if you do dot set upstream and set downstream, that's instead of those left greater than and less than symbols, you can do a dot set upstream and dot set downstream to set your upstream and your downstream dependencies. Okay. So here too, you can see this. I don't think you will be seeing all that. So this is the Apache Airflow Ui. Okay. And here you'll know how many times the task tried, and if you're trying to work on something and it failed, it'll show up over here. So you have very good UI. Apache Airflow is very good UI. Now, when I spoke about your external connections like AWS connections or something like that, here, if you see, there are some already there, you can go and create a new connection. You can say, okay, my connection, what's my connection ID? If it is, I think AWS is already there. Your host, I think AWS already there, will be there. So you can put in all your connection information here and then use your AWS hook to get your these connections and then work with AWS S3 or AWS S3 or Redshift. And then here you can put in any external variables that you need, like if you are your bucket details, if you are using S3 and if you have bucket details, you can put S3 bucket details here. So you can just pull in import your variables from here into your configuration file, which is your Airflow Python file, and use it from here. So that is Airflow. I think that's all I have about Airflow. And here I have all the information for that for Airflow. And I have additional resources that gives you where all the some of the resources that help me. It's here in references. So I think, yeah, I am done. So Mansi, Stephanie, so I'm done. So this is Airflow and Apache.
Hi. So yeah, there are a couple of questions for you. The first one is, until what point do you say the data already has quality?
Until what time part?
Until what point do you say that data already has quality, like it's clean, I suppose, like the Kaggle data sets are clean, right? So
okay. So if the current data set already meets your requirements, so when you start a project, you already have requirements, right? So if the current data set satisfies those requirements, so if you are setting it to okay, your nulls are 0 instead of null, or you whatever you decide on there, or the columns that should not be null, if all of that satisfies your business requirements, then you can say that, hey, yes, my data has quality.
Okay. Is it very important to know Excel well to be a data engineer?
Well is not necessary. If you are using the Excel regularly, that's enough. Yeah, data engineers, if you know Python, SQL, and you're working on the tools, you really don't need Excel. If you're analyst, if you're working as an analyst in any way, you're business analyst, that time you'll need Excel, because most of the time you may be on Excel. But if it's for a data engineer, you wouldn't need Excel, because data engineer's job is not analyzing data. Data engineer's job is cleaning data and finding out pipelines and working on this to be able to give it to an analyst, a data analyst who will analyze the data further. Your job is mostly as a data engineer will be to work on cleaning the data, on making sure the data satisfies the requirements, to creating pipelines, making sure the data is available, even dashboard creation, like it'll be, you don't have to analyze data. You just need to take in all of the data, put in a dashboard and give it to a data analyst or an analyst or a business analyst. So usually that is what happens.
Okay, so I think there were a lot of questions about what is Airflow for, and what are the uses of Airflow and its resources. So I think that is covered in the session. You talked about data swamp in between. So can you explain a little bit about that? What is data swamp?
It's a data lake, yeah. So data lakes, data swamps is actually the latest version to data warehousing. So in this, the data is available as like a data lake, right? It's a larger version of in warehouse. Usually the data is structured. It has to follow your atomicity rules of database, but data lakes is more little more not as strict, a little more lenient, in the sense that you can create a fact and dimensional tables and keep it there. So it's actually data storage, but it's not as strict as a data warehouse. You can have normalized and non-normalized data too, and depending on how you want it, you can start pulling in data. So sometimes normalized data may be too atomic, and you may have to do too many joins to be able to get the data out, and that will be very expensive, and your dashboard will face the brunt of having to do too many joins. So data lake is something that will have data in its third normal form, but also have it in first normal form, not too atomic data also will be
okay.
there. Yeah, not too normalized data.
Understood. Karen has a very detailed question for you. So her question is, my team has been creating our own scripts to handle the data pipeline and using cron job to automate the process. Do you think it's beneficial for us to switch the process to Airflow, since it will be an ongoing procedure?
Yeah, that is exactly where the Airflow will be very useful. You have a cron job running, and you're writing scripts, to handle that. Airflow is something that will take all of that away and just like keep it in, keep running all the time. So based on your schedule. So yeah, taking a look into Airflow and creating data pipelines would be very useful there.
Okay. Karen has another question. So also, does Airflow accepts NoSQL databases like MongoDB?
Yes, it does. You will have to create your own hooks. Sometimes the hooks may not be available. Operators may not be available. You may just use hooks and use, but yes, it will handle NoSQL. But again, this is Airflow is a pipeline configuration file. So you'll already have like an Apache Cassandra, something doing the modeling. So you're already using that database. But Airflow will be able to hook up to Apache Cassandra and get data and work on it and do the cron job.
Okay, understood. Each task is a Python file. So whatever we give it to Apache Airflow, is it a Python file or is it?
Apache file is, when you say give it to as a Python file, it's like creating the files as Python files. Apache uses, but if you're giving it, like you mean if you give Java, there's no need to give JavaScript, but if you're giving SQL data, you can give SQL data. Okay. But you have to give it in that, like I showed, like Python callable, right? Or Postgres callable, SQL callable. So you give it in that. You give in your code in that. But the rest of it will be Python.
Okay, understood. The last question is, what if your data is not so clean? If it has too many null or bad structure, how do you make it viable for data engineering projects?
So that's a good question. So usually in companies, if you're asking this for a company, then you need to talk to the person that's asking for the data and talk to them when you're like taking your business requirements or you're working on your requirements. You need to take a look at the data and say, hey, okay, we have these many nulls, we have these many. So with this data that I have, I may not be able to solve your question. Then they may tell you something else. Or if you're a senior data engineer, like as and when you grow in the company, you will know where all the data is available, and then you can, you can make a decision. Or so if you're a junior data engineer, you can ask a senior data engineer what you need to do with all these nulls. But if it, and then you can deliver the project accordingly. In companies, we discuss that. But if suppose you're doing it as personal project and then there are too many nulls, then you get to decide what you want to do. And you can even, chuck the data and try to get some other data and work on it. If the data is not satisfying your requirement or your questions or your motivation, your goals, then it's not worth using the data. Then it's not quality data. It's not high quality data to be used.
Understood. So yeah, those are all the questions for the session.
I hope everything was clear, because this is new and it may be very different and new to many people. Because usually when all this is new to me, it just went off my head. But this is Apache Airflow creating data pipelines, automated data pipelines, actually very easy. Once you get a hang of it, it'll just be at the back of my senior data engineers and all. It's like just like this. They'll be like, oh, go here, go there. I'm like, how do you know that? It'll be like that. But they know all that. So but anything and everything when you learn, it's difficult. That's the same way with this too.
Understood. Okay.
So those were the questions. If there is any other question. Oh, Sherry had asked, can you increase the other? Sorry about that.
Yeah.
When I went to the other screen, I think that became very small. Everything else I had increased. If there are any other questions, please feel free. I think Stephanie and Mansi will work on sending out the YouTube video and slides. So that will be helpful. Thank you all for joining the session. Hopefully it was helpful. My idea when creating the session was to bring what was not available everywhere, just to make everybody know that, hey, this is also available. This is something you can do. You can make your project shine when you add all of this. using Apache, because when I first told somebody in the company that, hey, I know what DAG is, they're like, oh wow, you know what DAG is? Oh great, okay. I didn't know when I joined the company what DAG is, so it was very kind of helpful. So
Yeah.
Okay, well, thanks everyone so much for joining us today. And big thank you to Anju for this wonderful workshops series. I think we all learned so much from this, and everyone's been a great audience. Thank you so much for all of your wonderful questions throughout the event and for your engagement. And please join us for future Women Who Code Python events. We're adding more events all the time, and join our Slack community, our social media communities, and we definitely look forward to seeing you at future events. And also wonderful job to Mansi for moderating today's session as well. So thanks everyone so much for your time, and have a wonderful morning, afternoon, or evening, depending on where you're located in the world. Bye.
Bye.